If you've ever tried standing on an office chair and blowing a raspberry as a form of transportation, you'll appreciate how difficult it can be to generate thrust. That's why rockets are so cool. There's nothing cooler than a rocket. It's a tube with fire that comes out of one end and speed that comes out the other. Recent advances in rocket technology have gotten an entire generation of nerds feeling pleasantly sticky in anticipation of what the future holds, which is great, because it seemed for a while that rockets weren't really getting much better. People went to the moon back in the late 60s, early 70s, but since then we've just been fanning about on the International Space Station. And as cool as the International Space Station is, it kind of loses its luster when you realise it's just a bunch of tubes filled with nerds trying to grow beans for a living. So we're wanting to get to some new and exciting places. NASA wants to go back to the moon and show it who's boss, and Elon Musk is staring at Mars and hyperventilating. There is a problem with us going that far away though. Well, lots of problems actually, but the main problem is the rocket equation. Presumably, God thought it would be funny to embed a big middle finger in the laws of physics when he came up with gravity, because the rocket equation is up there with a broken Rubik's Cube in a septic tank in terms of things that are unpleasant to solve. Here's how it works. Imagine you're on a boat filled with bricks, and for some reason the only way you're allowed to move the boat is to pick up the bricks and throw them off the back as hard as you can. That would push the boat forward because of the whole equal and opposite reaction thing. Not sure of a good in-universe explanation for this. Maybe you've got no arms and you're using your teeth to operate an onboard catapult. I don't know. Regardless, throwing the bricks is the only way you're allowed to move. If you're unsatisfied with how far you've moved by the time you've run out of bricks, you could always reset the experiment and try again with more bricks. But that makes your boat heavier. So you'll move more slowly until most of the bricks are thrown out anyway, so you won't actually go that much further. You could try even more bricks, but eventually you'll need an even bigger boat, which will also weigh more, and then you'll be whinging about not having enough bricks again. This is how the rocket equation works. Just substitute the boat for a spaceship, the bricks for fuel, and the ocean for a universe, I suppose. Also try doing this whole thing while fighting gravity and the atmosphere, and doing so with the same budget as an episode of Power Rangers, and you'll understand the gravity of the problem. But there's some obvious ways to address this problem. First off, this whole dynamic only exists because we insist on carrying the fuel with us. You could just say screw it and have something external push you. That's how a light sail works. You go to Asda or Walmart and buy some tin foil, unroll all of it and glue the edges together till you have a sheet the size of Luxembourg, then attach the most lightweight tin can to it for you to sit in, and hey presto, you've got yourself a goddamn space boat with sails being pushed by the light of the sun. If you want to go super fast for interstellar travel, you can always point a bunch of high-powered lasers at the sail from Earth. The only problem with that is you need about an extra planet's worth of energy to fire at this thing to get it going, and you need to keep the shield pristine as space dust pokes holes in it, and you need to slow down at your destination somehow. So there's a lot of problems. Anyway, it's theoretically possible. Then again, you could always skip the high-tech stuff and just yeet a rocket into space. That might sound like a solution dreamt up by a 7-year-old, and I imagine it probably was, but the folks at Spin Launch apparently took this idea very seriously and are currently working on it. So a big rotating arm launcher spins a rocket, like a cartoon character charging up a special attack, and then just flings it into the sky. They're still throwing a rocket which needs to be turned on, otherwise it'll just go in an arc and then pancake into the floor, but at least it saves fuel on the slow, crappy initial part of the launch. That said, you can't exactly launch people with this thing, because if you were to take a glance in the cabin after the crew's gone through this launch procedure, your crew would resemble a pile of torn spacesuit parts covered in bolognese. Of course, rather than doing any of these, you could just use more advanced propulsion methods. I know we're still a ways off from nuclear fusion, but hey, fission's been an option since the 1940s. You ever hear about Project Orion? A bunch of scientists thought it would be an interesting experiment to make a vehicle that can throw atom bombs out the bottom of the spacecraft as a means of propulsion. Yes, bartender, I'll have whatever you gave them. Believe it or not, this is not only plausible, but could totally be done today if not for the test ban treaty ruining all the fun. Seriously, it's kind of a bummer that there's no clause in there for, yeah, it's fine if you use them in space, responsibly, far away from people, definitely above the magnetosphere. Space is already filled with radiation, what's a little more gonna do? I mean, there are other options too. Nova thrusters, fusion eventually, antimatter, singularity drives. Depends how Isaac Arthur were getting about this. The point is, the reason space exploration is currently getting so much more insane than it used to be is reusability. Reusability, I hear you say? Do you mean they somehow circumvented the rocket equation to the point where they can just add fuel enough to do the mission and then also land? Yeah, that's exactly what they did. Like, just because you get diminishing returns on making rockets bigger doesn't mean you don't get any returns. So yeah, they've made the rockets bigger, and they're a lot more expensive to build, but if your rocket lands and then flies again, it's way cheaper on a per launch basis than one that flies once and then does its best Hindenburg impression. Spoiler warning, this reusability thing isn't getting old anytime soon. You may wonder why SpaceX is the only one able to make this happen rather than a national agency that's been working on rockets for decades, to which the answer is developing and building this sort of thing is very expensive. So you've got to throw money into a giant hole in order to get the ball rolling on this. Anything's possible when you have a bottomless pit of money to invest on a problem. SpaceX blows up a prototype and just makes another one in like a week and then blows that one up as well. I'm not making a judgment here, I'm just telling you that that's what's happening. That's what's happened, okay? I'm just the messenger. So that's the key takeaway here. If you have a problem, just try having enough money that your problem goes away. I know that's not very helpful for the average Joe, but it's not my fault you don't get to live my luxurious lifestyle. Anyway, I'm gonna go put on my 10th layer of clothing and hug a burning pile of garbage for warmth. Till next time.